Hi, I'm Mrs. D Math. Welcome back to my channel. If you haven't been here before, thanks for joining me. Today we're going to cover parallel lines and transversals in 8th grade math. A transversal, which is represented by T, is a line that intersects two lines in the same plane, or parallel lines, which here are called A and B, at two different points. So notice A and B are parallel, and line T is my transversal that runs, in this case, at an angle and crosses them at two different points. Now, I have labeled all of these angles that this transversal has formed with the parallel lines. We have 1, 2, 3, 4, 5, 6, 7, 8. And all of these angles have names that are going to help us understand what they mean. So we're going to start with corresponding angles. These are on the same side of the transversal and on the same side of lines A and B. So you notice I have circled 1 and 5 to match in yellow. So those are corresponding angles. Other corresponding angles might be 4 and 8 because they are both on the same side of the transversal and on the same side of lines A and B. They would both be to the right of the transversal line and below A and B. So 4 and 8 can also be corresponding angles. There is a lot of corresponding angles here. 3 and 7 and 2 and 6 are also corresponding. Now, in order to understand the next three, you're going to have to understand here that exterior is referring to above line A and below line B. Interior is referring to the space between lines A and B. So first we have alternate interior angles, and alternate just means that they are non-adjacent angles and they are on opposite sides of the transversal between lines A and B. So they are alternate, which means they are opposite of the transversal, and they are interior, which means they're between A and B. So 3 and 6 are alternate interior angles. 4 and 5 are also considered alternate interior angles. And if you can't remember, non-adjacent means that they are not side by side. Alternate exterior angles means that they lie on opposite sides of T, the transversal, and outside lines A and B. So 2 and 7 are alternate exterior angles. 2 is to the right of transversal, 7 is to the left. So that means 1 and 8 would also be alternate exterior angles. And the last one we need to know is the same side interior angles. So that means that they are going to both be between A and B, and they are going to be adjacent angles. They are going to be on the same side of the transversal. So in this case, 4 and 6 are interior same side angles, and 3 and 5 would also be same side interior angles. If you kind of look here, you will notice that when this happens, because A and B are parallel, I can see that these corresponding angles are equivalent. I can also see that my alternate interior angles are equivalent, and I can see that my alternate exterior angles are equivalent. If you can figure out what one of these angles equals, then you can use that knowledge and these definitions to figure out all the other angles in this picture. So if I were to tell you that angle 1 is 30 degrees, we know that a straight line equals 180 degrees. So I can use that information to figure out angle 2. So if I do 180 minus 30, angle 2 is 150 degrees, which means angle 7 is also 150 because I can see they're both alternate exterior angles. Since 1 is 30 degrees, its alternate exterior angle is 8, which is also 30 degrees. That means that 5 is 30 degrees, and 4 and 5 are alternate interior angles, so that one's 30 degrees. And that means the rest of these angles are 150 and 7 and 2 and 3. We know that a straight line equals 180 degrees. We can also determine that corresponding alternate interior and alternate exterior angles are equal to each other. So we can solve for missing angles using that information. And we just did a little bit of practice on the last example, but let's try one here. And in this case, we have variables. So we're going to use our information to figure out what the variable equals so that we can figure out the angle measurements. So my 3x here is going to be called angle AFG because I start at A, go to F, and then down to G. And then my angle 6x is going to be called DGH. I start at D, go to G, down to H. So I'm hitting the 3 points that form that angle. I can do it in any order, but I need that central angle G to be the center. And in this case, F is going to be my center letter. So now let's figure out how we're going to solve this problem. So we do know that 3x and 6x are not equal because they are not corresponding, they're not alternate interior, and they're not alternate exterior. 6x is an alternate exterior angle to this angle up here. And we know that 3x and this angle, F, are going to add up to 180 because they are on a straight line. So that means that 3x plus 6x is also going to equal 180 degrees. Now I'm going to solve this just like an algebraic equation. I can combine like terms because 3x and 6x are both a variable of x. They match. I can add those together. So 9x equals 180. Then I can solve my one-step equation by dividing both sides by 9. And I can see here that x equals 20. Now I can use that information to plug that in for x to solve for the actual degrees of the angles. So 3 times 20 equals 60. So that means that this angle right here is 60 degrees. And I know that 6 times 20 equals 120 degrees. So that means that 6x is 120 degrees. And I also know that 120 plus 60 equals 180 degrees. This also can help me figure out all my other angles because I know now that all these obtuse angles are 120 degrees and all my acute angles are 60 degrees. I hope these definitions help you understand how to find missing angles when you have parallel lines cut by a transversal in 8th grade math. I'm Mrs.D. Math. Thank you for joining me. I hope you have a great day. Bye.